Welcome to this next episode of Fire and Wire. I'm here on the Banbury Road. I've got this beautiful old building behind me, and you wouldn't believe it, despite its age, inside is the high-tech Robotics Institute. And we're going to go and find out a little bit more about what they've been doing to drive and make robots for good. This is the team which just recently won the Queen's Anniversary Prize for their brilliance in all things robotics. So let's go on in and let's find out a little bit more from the director of the Institute, Professor Nick Hawes.
Great to have you here.
Oh, well, I'm absolutely thrilled. Thank you so much. We got lucky with the weather.
Just about.
And I know you got a real treat for us in store. So, Nick, maybe we could just kick off by telling a little bit about yourself and your background, and then your role here, and a little bit about the history of the Robotics Institute.
Yeah, I'm a Professor of AI and Robotics in the Engineering Department. I'm also a tutorial fellow at Pembroke College, but I'm here as the Director of the Robotics Institute. The Institute was founded by Paul Newman and Ingmar Posner about seven years ago, building on their history. The foundational work for autonomous driving. That was what Oxford was known for in the noughties, kind of 2010s. And then in 2017, the Robotics Institute was founded based on the back of the success of Ingmar and Paul.
Fantastic.
That's commercial now. That's gone off into Oxford, which is Paul and Ingmar's company. And now we do every other type of robot you can think of. We do legs, we do hands, we do wheels, we do a bit of drones, we do human-robot interaction, we do ethics. All of this is underpinned by artificial intelligence and engineering.
Fantastic. And it was for the breadth of it that you won the Queen's Anniversary Prize. So congrats once again.
Thank you very much.
So awesome to go there to Buckingham Palace that day.
The whole Queen's Anniversary Prize system is looking for the societal impact of research. So whilst they awarded us for the quality of the research, they looked at the kind of impact we had on transport, on robotics in nuclear, on space, and increasingly on things like social care. These are areas where robotics can have a huge value. As
well as just the sheer fun of playing with robots, which we all love.
I mean, that's what the best research is, isn't it? It's both excellent science, but fun as well. We all do it for the love.
Yeah. Well, I think it's time we saw some robots. So here we go.
You should hear the robot start to move. This is a Spot. It's a Boston Dynamics robot.
Yep.
One of the things we do here a lot is, you can hear it, we buy a lot of our robots and then use them as platforms to deploy artificial intelligence for decision making, perception, and then use them for applications. And so here it's just doing an inspection action, so it's pointing its cameras up to a target that we've proposed. I'm just going to get out of the way so you can see.
Absolutely. Let him come through.
Yeah.
Him, I don't know why I'm saying
it's
to
not.
him.
We don't gender
let Spot
robots.
Come through. We shouldn't gender them.
We've been doing work with the UK Atomic Energy Authority to do inspections. So in areas where you want robots to be, but you don't want humans. Then these robots are excellent for that.
Was it deliberately made for that low movement?
I think it's
it just gives it more flexibility?
Yeah, I think it's just about, it gives it more control, more flexibility.
So it can rise and...
Yeah, so it can lift up higher, it can go down. We're deploying it under a nuclear reactor by the end of the year, where it's going to crawl through what's called a bioshield, a small tunnel. So it's going to be as low as possible, crawl through, then go up and inspect around the bottom of this reactor.
Take pictures and everything?
Build a 3D map that they're going to use as part of the decommissioning process. It also saves money, so that decommissioning process, the mapping under this reactor, will cost over £1 million if you did it by hand, or like with humans. But we can do it for tens or hundreds of thousands of pounds with the robot and the project. So when you see Spots at science fairs or at trade shows, you need to look at what's on the back. If there's nothing on the back, then they've just used it for dancing.
Then it's just a gimmick.
Yeah, so if they've got a payload, if they've got cameras, if they've got LiDARs, then they're actually being used in reality. You can also see
what weight can it take then?
Oh, I don't know. I'm going to say...
I couldn't sit on it.
You couldn't sit on it. No, our risk assessment doesn't allow that. I've been in so much trouble. But you can also see kind of the bumps and bruises where it slipped downstairs or turned over. They're really robust. Yeah,
fantastic. Right, well, let's go on and see some more. Bye, Spot. You should get it to talk.
Yeah. People behave completely differently when a robot speaks. It's really, really interesting.
I think people react very differently.
This is down to the lab.
You've got to tell me why you are calling it the Bat Lab.
It's underground,
like
Batman's lab, and it's full of exciting technology. There's nothing too deep about it.
So you're the Batman, and who's Robin?
You can pick. You can pick today.
Okay,
you can pick
very
a Robin.
Good. I will. I will. What was that? Oh, hello everyone. Wow. Oh my God, this really is like a bat cave.
My colleague, Professor Irene Tracey.
Yeah, I know Ingmar, of course. Professor, good to see you again. Thank you for letting me come and visit.
Welcome to the RI. Welcome to our lab in the HB Allen Centre. In the ORI, most of the science we do is pulled through applications, and it's really quite important because it really focuses our research. One of the things that we're also very keen on doing is engage early with stakeholders, and particularly I think in social care that's really important because you don't want to be the guy who shows up with the autonomous pill dispenser that nobody needs, right? Turns out that one of the key causes for hospitalization out of care homes is not drinking enough.
Not drinking enough water.
And so one of the things that we had in mind as something we could do with some fairly basic robotic science is automate that system.
Right.
And that was the birth of what we now call the Good Hydration Project. Okay. This is one of those robots, one of the stretch robots manufactured by a company called Hello Robot. It's very basic, so you don't see a face, you don't see anything human-like, and that's because ultimately, you're supposed to think of this as a tool.
Yeah, it's a functional tool.
Exactly. Yeah. So if you think about literally taking like a large language model like ChatGPT or with a vision input and so on, onto one of those robots, and you want to interact with these robots with pure language.
Say that I don't want an orange, I want an apple juice.
For example,
something like that.
The language model knows about language. It doesn't know anything about the robot workspace. So grounding all these things, like I want this bottle in the robot workspace, and also the robot embodiment, how to interact with it, is a pretty critical thing for us.
Absolutely.
We're hoping to get this into a care home in the next few months as a first sort of trial. I'll take you to this guy. Right. This is Frank.
Right. Hello, Frank.
Frank rolled out of a crate about 8 months ago, and we've been commissioning it ever since. So this is sort of the last stage of commissioning before we do the research bit. And the idea for this is to really work on small batch manufacturing and assembly. So there's a lot of work going on in the robotics community right now about manipulation and how we do that robustly. This is Alex.
Hi, Alex. Good to meet you. Thanks for
Alex
letting me come into
has done a lot of the integration for Frank of it and the software framework for it.
We changed the controller, so rather than being very rigid like most manipulators, it's actually quite soft. And pliable, so you can actually have a play.
Oh yeah.
And you can push different joints. So if you were to, if it was interacting with you, it's not going to harm you. It's very soft and compliant.
It's not going to punch you in the face.
Exactly. So now we'll do another thing as well, which is really cool. So it actually understands a little bit about itself. So if we rerun this, what we'll try and do, it'll try and do a similar thing where it tries to pour from one hand to another. But I can be a bit of a bully, you see, and it will try and react to it. So I can sort of move it around very gently.
And the other one's chasing it.
Exactly. And then if you'd like to have a go yourself.
I would love to have a go.
Pull towards yourself.
I will. Yeah. Oh yeah.
And then this arm will
He's
gently follow you. And then if you bring towards me again.
Yeah.
Sorry, it's a bit. Let me give you a
Yeah. Gosh. And you were saying you can show it doing some sort of more complex assembly.
Yeah,
I mean, that cup thing was pretty impressive, but let's have a look at what else it can do. Okay, sounds good.
A few seconds, sorry. Bear with me.
Okay. I've got every confidence in Frank. Here we go.
Right, let's just see how it goes to start with. Doing a very good job. Oh,
I did it. Yeah, I did a great job.
Sorry,
Now, less surprised when it does that.
You have no faith in Frank. You've got to trust Frank. Yeah.
Really, I should trust.
I was watching a documentary on agriculture, and they had this amazing robot going along picking strawberries out with incredible precision. Frank's done well, but this looks like it wouldn't be as good as that robot at picking strawberries, but that's not the point.
We tend to develop technology here that embeds into its workspace. So, for example, if you have a particular product that you want to build today, and you only want to make a small number of that, hence the small batch part, you want to instruct your robot in a fairly natural, sort of organic way in order to be able to give it new skills
so it can do new
for a
things.
particular
So that strawberry picker wouldn't be able to do anything else but pick strawberries and a particular type of strawberry.
Typically,
and that's it. Whereas this robot could be trained to do the strawberry, but it could be trained to pick a pear or an apple or build things. That's the difference.
Yeah, and that of course it's not tied to that robot. So if you happen to be a small batch manufacturer or you do something in industrial assembly, you don't have to have bimanual Frank. It can be a single arm, it can be two arms, it can be more than that. Right?
Okay.
And so the question
just the
then
principles
is,
of
how can somebody who's not a roboticist go in and go, well, actually, I need to be able to do this quickly. Let me now introduce you to my colleague Perla Maiolino.
Good to see you again. Good to see you again. Yeah. I can see you've got a patient here in some pajamas.
Yeah.
What on earth is this all about?
My research is about soft robotics and tactile sensing to help occupational therapists to train themselves.
Right.
It's actually very difficult for them to understand how touch patient and also recognize their feedback. So what we're doing is actually creating a system that can be programmed to mimic different patient profile, and so they can touch, see how much pressure they are applying, and also get the feedback from the sound. For example, here there is all the skin, and there is also a point that indicates a most painful point where to apply pressure. And also, if you apply pressure here, you heard the sound. You need to touch like on the spot.
As a pain researcher, I'm
and
very familiar with doing this.
And you see the response, like, and the color mapped how much pressure you're applying. So we can record all this information and process at a later stage, so they can see how well
they're doing
perform at the operation.
So it's very much to use sensory feedback. And is this something they've identified that they need in talking to the occupational therapists? They feel that this would be helpful for their training?
They express the need of systems such this one because usually they need to practice among themselves. So, and it's not easy. So you need a lot of years of practice to be able to master the technique. Also, there are aspects between functional and affective touch that are very, very important because it's not easy to, touch properly a patient and not surpass some boundaries of
privacy.
Privacy.
And it's interesting, isn't it, with the pandemic and even though that was a few years ago, we realised the importance of physicality and contact and touch. And
nurses were actually using latex gloves and filled with warm water to put it on the patient because touch is so important, and we need to explore this domain more and endow robots with this sensing to be able to interact with the world.
Absolutely, Well, best of luck with the work. Thank you, Perla.
Thank you so much. Thank you. It was nice to have you here.
Let's go on to
I work on one of the underpinning technologies of robotics, which is 3D mapping technology. And over the last number of years, we've developed a handheld device that you saw on the Spot robot earlier. I'll just talk a little bit about what it contains. So you can see here a prototype device. It's got 3 separate cameras that are attached to it, and a laser here, the same type of laser that's on an automotive self-driving car, and some computers on board to build a 3D map of the environment. So it's spinning around and scanning, measuring a 3D reconstruction.
So the cameras are doing the pictures and the lasers picking up the sort of geometry.
Exactly.
Great. Okay.
And we can use that as a basis for navigation on a variety of robots, aerial robots, underground exploring robots, the Spot that we saw earlier. And this was actually a project where we were mapping diversity and growth in forest environments. So you can see here the robot exploring in the forest environment, building up a 3D map, identifying each individual tree, measuring its radius and its volume. And you can see here kind of reconstruction of each tree, how big they are and their exact positions, this kind of thing.
That's fantastic. Wonderful. That's amazing. I can see the use more and more for sort of sustainability and again conservation monitoring, agri-tech. Who are your main customers? Is it construction or?
Construction companies, and then maybe more specifically companies that wanted to do this regularly or very quickly. Architects who are doing bidding for jobs, they want to have a more detailed model. They don't use very much technology in this sector.
One of the things I was really keen to hear is how many spin-outs are coming out of this. So I'm really thrilled to hear this, and nice to see that you celebrate success as well.
It's important
with
to
some
have
fine
a team.
dining. You've got to. It's very important to have. And thanks for sharing your time here.
Thanks for your time.
Right. Okay. Ready? Thank you very much. Well, Nick, I can't thank you enough. That's just been mind-blowing just to see not just the breadth of what you're doing, but the quality and the depth of the research that's underpinning it. And I love your philosophy about, the Institute being really focused on robots for good and what it can do for society. But I'd love to hear sort of what your vision is going forward, with the Institute and where you see the new barriers that you want to break.
The vision of the future, as you said, is robots for good, for impact on society. And not just robots, but the underpinning technology. So the artificial intelligence or the control or the mapping, all of these things, we contribute to robots, but we also we could contribute to a model of the planet. For example, as you map the planet, you could build a digital twin of a forest, you could build a digital twin of the ocean, and you need to feed those things with data, which you can use robots for, We want to use these robots to augment and amplify human capability. We're looking at things like mine clearance or unexploded ordnance detections. We've got a project with the Halo Trust just starting off.
Well, that's such an important charity, you know, their work on landmines,
And it's just somewhere where robots are kind of perfect. Whilst they use some technology, there's the ability to scale and get people out of harm's way is great. We've got a new CDT in robotics and AI for net zero, so that's with Manchester and Glasgow. And so we're looking really how we can accelerate the kind of green revolution and sustainable power using robots to decarbonise the life cycle of all sorts of energy assets. So there's lots of areas like that we're looking for.
Space, you haven't mentioned so much on space or the robotics and things, because obviously we've got, you know, we've got a huge astrophysics department here, and we've got a sub-department of physics, and we've got the atmospheric and planetary physics department.
So no, absolutely. We've got some, I mean, space is a real driver for autonomy because of the communication delays, even if you're in orbit, if you're on the moon, if you're on Mars. You can't remote control a robot there. So you need autonomy. You need that also that general purpose capability, not just, you know, specialized, not just picking strawberries. We need a robot that can do anything if we're going to use it to explore other planets. So some of the work that Paul and Ingmar did in the early days is actually flying on the ExoMars mission on the Rosalind Franklin rover. Some of the visual odometry that was used on the cars is now being used in space. In terms of underwater, so some of the decision making that you saw on Spot at the very beginning, we're putting the decision-making algorithms from my group onto underwater gliders. And instead of long-term monitoring outside spaces, whether it's construction sites or quads, we're trying to long-term monitor the ocean and use the autonomy to drive the gliders to sample bits of the ocean where the climate models or the forecast models are bad.
Are you getting enough people coming through with STEM backgrounds to support your ambition?
The huge hype around artificial intelligence at the moment is both good and bad. We do a lot of AI in this institute. And so the excitement around that, the new technology is great, but I'm missing out that robotics is a key element of that. If you ever want an AI system to affect the world, pick up some waste, help a human out of their chair, you need the robotics. So there's an element of, if you're doing something that's purely computational, it's kind of quite easy. You can pick up a data set, you can pick up algorithms, you can go through tutorials online, you can do that on a laptop in your bedroom. Working with robots is a much slower process. I think the output is so valuable, and the excitement when your robot moves, when you see those things move, when your code drives that robot, it's incredible.
Well, you can see that in the Bat Lab down there.
Everyone's just excited.
I was buzzed. We just put a little screw in a thing. It's magical almost, you know, to see.
But how you get people to experience that for the first time and reinforce that, even though it's slower and more difficult than simply programming, I think that is a challenge in this sort of sales pitch of robotics.
Well, people are scared too. I mean, maybe that, you know, there are some ethical challenges.
I think what we've learned from the kind of field trials and the deployments we've done. So, for example, there's a robot behind you called Betty. We used Betty in hospitals, care homes, and office settings for 3-4 months at a time. And we did social science studies as well as artificial intelligence. And those social science studies showed us that if people understood why the robot was there, and kind of understood how it was doing what it was doing in a very, in a fairly conceptual way, that really increased the acceptance. People were not comfortable if robots just appeared in their workplace because without a kind of an understanding of what their purpose was. So I think that's, for us, that's part of the answer. These robots should add value to whatever you're doing. And if you don't see that, then the place you're in or the people you're working with are not communicating it clearly. So automation needs to be done sensitively.
You know, society is getting more comfortable. You think about Siri, you think about Alexa, you know, so we're by stealth getting society comfortable to live alongside sort of robots, if you like, or automation. So that probably will help in terms of acceptance and tolerance.
I mean, the idea that you can talk to a kind of consumer electronic device and it does something useful to you, it's now embedded. My kids do it. My mum does it. You know, that's definitely part of it. Connecting that to the physical world, though, is just so much harder. And really, seeing these things in our home, it will happen, but we're still a long way off, I think.
Well, it's been a real treat. I can't thank you enough for giving us so much time and to your whole team to let me come and see this. It's been just, I'm really buzzed and energised about what's possible, but it's been a real thrill to come over and visit, and best of luck and congratulations again. Thanks, Nick.